characteristics. Oh, that's the wrong one. Characteristics of a function. Now, what we have here are two tables, and they're going to be our first and second example. This will be our example 1 and our example 2. I put them in table form, but there's many different ways to represent these, and then we're going to decide if we have a function or not. There's a lot of words we haven't really discussed yet. So first of all, this is in table form. So if anyone were to ask you to put coordinates in a table, this is what they look like. If we want to write them out as coordinates, each of these pairings is a set of coordinates. Okay, so I'll do this for the very first table, but I won't do it for the second one. We can rewrite them as coordinates. We have the coordinate of -3, 5. That's a point. We have the coordinate of -2, 4. That's another point, so maybe point 1, point 2. We have the coordinate of 1, 2. That's our third point. Our fourth point is 5, 2, 7, 1, and 8, 0. Whoops. Now, if you notice, the table's probably a little easier to read rather than this mismatch of coordinates put together. So a table is one way we can represent it. Another way we can represent coordinates is on a graph. And a graph is something we're probably used to seeing. So we're going to pull up a graph here, and I know you guys can't pull one up as easy as I can, but let's take a graph out. Okay. So we have our graph here. We're going to label all of these coordinates on the graph. So the first one being -3 and 5. So the x is -3, and the y coordinate was 5. So we have a point right here. In fact, we can call it point 1 if we like. Okay. The next one we had was -2 and 4. -2, 4. That's our coordinate 2. 1, 2 is the next one. So we go over on x, 2 on the y. That's our third. 5, 2, which is here. That's our fourth. 7, 1, I think. Yep. 7, 1 is our fifth. And 8, 0 is our sixth. So here are our 6 points represented on a graph. Okay. These are the exact same coordinates we talked about before. They're just represented differently. In the first one, we had them in a table. Next, we wrote them out as coordinates. Then we wrote them on a graph, all representing the same type of relationship. Okay, now these are specific points. This is not a continuous line. So this is just 1, 2, 3, 4, 5, 6 specific points. And finally, the way we haven't seen before is we can draw what's called a mapping diagram. Okay? I need a little room for that. A mapping diagram is very similar to a table, but when we have points or coordinates that are redundant, we don't rewrite them. Okay? So a mapping diagram, I'm going to look at all of my x values. My x values have -3, -2, 1, 5, 7, 8. Okay, none of them repeat, so I'm going to write all of them out in order. -3, -2, 1, 5, 7, and 8. Okay? My y coordinates, I'm going to take a look at those. So this is where we're starting to separate coordinates. We put all the x's in a column. Now we're going to put all our y's in a column. In a table, we write how they relate to each other. But if you notice our y's, we have 5, 4, 2, 1, and 0. I'm not going to write the number 2 twice. I'm just going to write it once. Okay? 5, 4, 2, 1, and 0. 5, 4, 2, 1, 0. Next, talk about how they relate to each other. We're going to be drawing arrows between them. Okay? So, the number -3 related to 5. -2 related to 4. 1 related to 2. And the number 5 also related to 2. So we have an arrow from 5 going to the exact same point. Okay? So that's how we represent 5 being the coordinate of 2. Then we have 7 at 1 and 8 and 0. This is how we would write our relationship in a mapping diagram. Okay. So this is our mapping. Our mapping diagram. And finally, we're talking about something called domain and range. Domain and range talk about coordinates in our points. So domain represent all of our x values. Since this isn't continuous, we're going to write out the x coordinates. And they're very easy to see from a mapping diagram what our domain is. Our domain are all of the x values. So in this case, -3, -2, 1, 5, 7, and 8. These are x values. Okay? Our range represents our y values. And again, from a mapping diagram, it's really easy to discover what our range is. Our range is 5, 4, 2, 1, and 0. And that's it. We've separated. So I've now shown you a table. That's one of them. Coordinates is 2. A graph is 3. Mapping diagram is 4. And domain and range is 5. That's 5 different ways to represent relationships between numbers, or in this case, functions. So what we have here is technically a function. Our first example is a function, and I'll tell you why it is a function. The reason this is a function is it does not have any x values that repeat and have different y coordinates. So really hard words to understand, but it's actually the easiest to see when we graph it. What I'm looking for is any point where I have two x values, so x at 1 and 1, let's say, and another coordinate at 1 and 2, where if I were to draw a vertical line, it would hit more than one point. So in this function, if you guys notice, if I draw a vertical line through all of these, I'll let that one fade away for a second. There we go. These vertical lines only touch one point at a time. If I ever draw a vertical line where it touches more than 1 point at a time, it is not a function. So the best way to do this is, whether they've given us as tables, coordinates, mapping diagram, domain and range, is probably to graph it. And once we graph it, it'll be easiest to see by drawing a vertical line. It's known as the vertical line test. So what we're going to do next is, I'm not going to write the coordinates of this table, but I am going to graph this. Okay? So we're going to quickly graph these points. First one being -4 and 5. We've got -4 and 5. Second one being -1 and 4. 0 and 3. Then we have 1 and 2, 1 and 3. 2, 1 and 3. And 9 and 0. 9 and 0. Okay. So if we take a look at this function here, if I'm to draw vertical lines through this, this one's okay, this is okay, this is okay. What happens right there? It touches more than once. So because this touches more than once, the second example I give you is not a function. Okay, this would not be considered a function because it does not pass the vertical line test. The last point does. But it's because that one error it makes, this is no longer a function. It doesn't mean we can't represent it as a mapping diagram or a domain and range. It just means this is not a function, where the first one is a function. Okay, we're going to put it into a mapping diagram. My x values were -4, -1, 0, 1, and 9. -4, -1, 0, 1, and 9. Those were all the x values. All the y values were 5, 4, 3, 2, and 0. 5, 4, 3, 2, and 0. So they'll also be a little more complicated on this one, but they'll also help tell us that this is not a function. You'll understand why. First, we're going to match up -4 to 5 and -1 to 4. So -4 to 5, -1 to 4. 0, I think, matched to 3. The number 1 matched to 2, and it matched to the number 3. So number 1 matched to 2, and to 3, and 9 to 0. So, in mapping diagrams, you can also tell something's not a function. You'll notice that an x value will have 2 arrows coming from it. If you ever end up with that specific case, that means it's not a function. In the first one, we don't have that. We do have more than one x value going to a single y point, but that's fine. There's nothing wrong with that. But if you ever see 2 arrows leaving one of the x values, that means we don't have a function. Again, probably the easiest way to tell is by graphing. And finally, let's do our domain and range. Our domain is just all of the x values, which in this case is -4, -1, 0, 1, and 9. And the range being 5, 4, 3, 2, and 0.